morning, good evening, good night from southern Germany, from Nuremberg, where today the SPS show starts. SPS means Smart Production Solutions, but SPS is also an abbreviation which we use in German.
Yeah, it's speicherprogrammierbare Steuerung, right?
If you translate this back to English,
it's control, logical control.
Programmable logic controller. And this will be one of our highlights today. A commodity in automation completely rethought. We have prepared 30 minutes of automation technology for you on our booth here in Nuremberg, and of course you are most welcome to visit us. But Roland, we are now taking a wild ride through automation technology. If I have a question, how can I voice it?
Well, we do this now in year 4, our live and interactive stream, but some things are always the same. This is the way to get in touch with us. Easiest way, use the chat window. You can type in questions or remarks, and we have a team behind us who can answer technical questions right away. If you like it a little more private, then use meet@beckhoff.com, our special email address, and you can ask your questions, you can ask for contacts or any further information. And last but not least, you can always come to Nuremberg and see us actually live if you want to.
And now you can see Roland running because you have a meeting with Hans to talk about automation technology and the automation brain.
Let's get the show started. Now, this trade show is over 30 years old. It started in 1990. And since 31 years, actually, Hans Beckhoff is part. Hello, good morning, Hans. I calculate this is your 31st SPS trade show.
In 33 years.
Yeah, we were missing 2 years. Now, if you come to the booth and look around, is this still, how is your feeling about this?
It's still a little bit the old feeling. So we to have a look at the own products or the own booth, at all this exciting technology which we are presenting to our customers. This is always a good feeling. And it's different compared to 33 years ago. No? Because this was the second year of the SPS show at all. And it was a very small hall in Stuttgart. It was not in Nuremberg. And we had a very small booth, 6 times 6 meters, and now we have nearly 2,000 square meters. So it's a little bit of difference in between, but it's still the same competition, Olympic feeling. I'm always calling this the Olympics of automation technology. And we are part of it.
Yeah, and if I look around now to the Olympics, I mean, we have the different forums here.
Yeah, the software forum over there.
Behind us now is TwinCAT also now. Motion, it's amazing, isn't it?
Motion with all these standard types of motion, X-motion as we call it, with the XYes and X-planar and Atro, the robot. And over there is the I/O part and our technology forum, which presents our use technology. So it's a perfect show.
One thing is always in common, and it's about automation. And you yourself, you take a synonym, because you said it's the automation brain. So you compare the human evolution with the automation evolution for Beckhoff. So why do you do that?
Yeah, we want to take some inspiration from the experience of Mother Nature. And over the millions of years of development, the result of this evolutionary genetic development is the human being. So so we can look at the human being, how it's functioning. So where is the intelligence? Where is the control algorithm for the motion of the human being? And you know this, it's in the brain. And so the brain is the central control organ of the human being. And Mother Nature decided to develop a lot of decentral motion, actoric, sensoric, but then it decided to bring all this information about these signals to the brain, here in the brainstem, and present it to the brain. And the brain then has a modular structure for motion, vision, talking, and intelligence and so on. And we do exactly the same with our TwinCAT philosophy. So TwinCAT is a software automation brain. And you look, such a robot like here, it's looking very similar to me.
Powerful, elegant shape.
And it needs a brain. And a robot has to move, so it needs a brain which can do movement. And it needs a brain, if we attach a camera to it, which can process vision. And we need a robot who can speak to us, so we can say start and stop to the robot. And we need a robot who has some artificial intelligence for developing some strategies. And all this is in TwinCAT, and so we can draw a map of functionality of TwinCAT, and beside this you can do a map of a human brain, and you see a lot of similarity. Therefore, automation brain is the way to go.
Yeah. Nevertheless, at this trade show, people always discussing the difference between central and decentral automation. Now, does this goes along, or is this a separate?
It's going in parallel. Huh? So you see, such a robot needs a central control, also a tool machine, because a lot of movements have to be correlated, and this is done in the best way that you have a central controller which is running a mathematical model of the complete movement, and not with a decentralized motion intelligence. So their Beckhoff is clearly positioned on the centralized part. But if you have a very big assembly line, then you can segment the assembly line into different sections, and then for sure it's maybe intelligent to give each segment its own control. And this is then a little bit decentralized. But if you look into the decentralized segment control, you find once again it's by principle a centralized functionality for this segment. Huh? So, and because Beckhoff is building big controls, which can control the whole assembly line at once, and a lot of small controls, which can be used for controlling one segment only. So it's up to our customers to select which way to go.
Okay, well, way to go. Let's go a little way. You just mentioned already one Beckhoff buzzword. This is TwinCAT.
Yeah.
Because TwinCAT is inside the brain, basically, and makes the control.
It can do the software brain.
It can do the main central, it can do the decentral. But TwinCAT is built 1969. So it's almost
1996.
So it's almost 30 years old.
Yeah, that's true. Yeah.
Is this still state of the art, or is TwinCAT just old, slow?
No, it's no, it's the most modern control architecture you can think of, because it's completely software-based. All functionality we are delivering to our customers is realized in software packages, in small modules of software, and all this together is then installed on a standard operating system, which may be Windows, Linux, or BSD, or other ones, and therefore we have all the functionality in this one software package. And also this is reflected, for instance, in the in our technology departments inside our company. So we have more than, or nearly 300 development engineers and product managers for TwinCAT, and they are building small groups of experts, about 20 to 30 groups. There may be experts for motion, experts for OPC UA communication, experts for TwinCAT, experts for loop control, for vision, and so on. And all these different groups contribute to this one package TwinCAT, and so we can deliver to our customers an integrated solution consisting out of the PLC functionality, the motion functionality, the vision functionality, and so on. And this is our leading philosophy, to give all the features you need for the automation of a machine in one package. This was true in 1996, and it's still true very much today.
Now, when we started, there was one PC and there was one Windows, and then we put TwinCAT on it. If I now take a look to the flexibility we have today, we have multiple hardware platforms in IP20, IP65. So is this variety necessary, or wouldn't be just one IPC enough?
No, it's the big advantage is that our basic know-how is coded in software only, and we can scale it onto different level of hardware platforms. This may be a high-end 64-core big iron PC, as we call them, for very demanding applications, but it may also be a 200 euro priced small controller, which is already capable of running the TwinCAT PLC, not the neural network or something like this, but the basic functions can be done, and so our customers can scale in terms of performance and in terms of price in a big, broad range.
And I think this reflects also the variety of applications we have, because I think the variety of applications,
that's true.
Because our customers do everything you can imagine, from the really huge machine to a very small control application.
It may be a small transportation band, and it may be a machine where we control 150 axes with one PC. so complicated battery production machines, for instance, the winders, they are quite complicated, has a lot of movement inside. And one of the advantages of Beckhoff technology is that we can build a mathematical model, that we then have very clear functional principles after the machine is working. And this is very much accepted by our customers because it makes these big machines manageable.
Yeah. Yeah. Now, when I now take a look into our TwinCAT forum, maybe we just stop here, sneak around. Now,
already crowded.
Yeah. Behind us is the TwinCAT highlight forum.
Yeah.
And we've built this out because there is a TwinCAT highlight. So inside our TwinCAT development teams, one team created a new highlight. So what is the highlight of this trade show?
Yeah, we have some highlights. But in the software area, it's for sure it's PLC++, our new PLC compiler, which opens up new dimensions of performance and which allows our customer also to optimize their engineering and to optimize the performance of the machine.
Oh, perfect. And performance matters. This was our slogan already at the last trade show.
Speed matters, yeah.
So I think we hand over to Felix and to Bela because they will talk about PLC++. Hans, thanks for the introduction today and have a wonderful day.
Thanks. Bye.
And PLC++ has already been everywhere, so you might have seen some news, some advertisement around it, and we already got a first question from Czech Republic when we will introduce you to TwinCAT PLC++, and the answer is obviously right now. But for me, it's still a difficult topic because I am not a software guy. So, Bela, when I hear PLC++, I know C++ as a programming language. Is this now our standard for PLC programming?
So no, it's not, to be honest, but I think the comparison is still quite valid because we also took the PLC technology a step further by developing a fully new PLC compiler, which again, by the way, combines OT and IT world as it's typical for Beckhoff. For this compiler, it means that we highly confirm with the IEC 61131 standard, and also the standard programming languages, by the way. But we also introduce a totally new feature from the IT world, which is the optimization possibility during the compile in terms of runtime performance. So you can have the same code in PLC++, and it can be executed up to 3 times faster in the new PLC++ world in comparison to the existing world.
Okay, so you basically can have a PLC execution boost, and then it's much faster. But speed is not the only thing when you want to programming a machine. What else do you need to have a modern PLC system?
So I think efficient engineering is one of the second most important things. So we really focused on engineering performance. This means smaller loading times, compiling times, but we are also adding quite a number of usability features based on the 27 years experience with TwinCAT we already have. And those features are very important for the users because they support them during the standard programming, the daily business with TwinCAT PLC++. And talking about the topic engineering, I would also like to concentrate on CI/CD because efficiency is also very important in this topic. This means for us that we are designing the compiler that way that it is a standalone component. So it can be really seamlessly integrated in such automatic build processes, and the engineering no longer has to be loaded in the background because nowadays it's also possible, but it will be way faster and more efficient.
Okay, now the engineering with PLC++ gets faster, more efficient. You have some IT standards which you can utilize even better today. But to be honest, a lot of engineering effort has already been spent on TwinCAT PLCs.
Right.
What about all the projects which have been tested, validated, deployed, developed, thought through, thrown into the trash can before?
So this is another important topic. We built TwinCAT PLC++ to be 100% compatible with the existing world. This means we have standard TwinCAT build 4026. This is what we are also showing on our workstations here. We do have standard PLC libraries. We have the standard TwinCAT functions. So everything else, except of the PLC component, stays the same. You simply exchange the PLC component, update it to the new PLC++, and that's all you have to do. And for updating, we are also providing, of course, a converter. This converter can be used to easily convert existing knowledge, PLC code, to PLC++. And if you would like to have a change step by step, then this is also easily possible because TwinCAT PLC can be executed next to TwinCAT PLC++, so you can start with the first feature implemented in PLC++.
Okay, so more comfort. But I think speed really matters. So let's maybe get back to the runtime optimization and the advantages which we have here. If I tick on the speed option in TwinCAT PLC++, then this is what you get. Can you explain us very briefly what we can see here?
So what we can see here is a standard TwinCAT application besides the TwinCAT PLC++ optimized application. Okay. So this is the tick you are mentioned. But it's exact same PLC code and the exact same hardware. Okay. And we can reach here, and you can see this easily within the scopes. You can see that we have up to 3 times faster execution time on the PLC++ optimized application.
That's half a microsecond versus half a millisecond versus 1.5 milliseconds. But
absolutely,
do I really need that? I mean, that's a millisecond.
That's right, but I think this should be a very important topic for all of the users because having shorter execution times means you could also use shorter cycle times. And this again leads to faster response times in the application, and it's a base then for a higher output of the machine. Okay. And nevertheless, it also has of course effects on the load of the CPU because it's less time needed. You have more resources available for running additional features, but also maybe choosing a smaller IPC, which would also be possible.
So more performance and, if you like, also the possibility to scale down a little bit hardware-wise. So also a money saver, but most and foremost a big leap forward in terms of performance.
Absolutely.
Thank you, Bela. I hope you will have a wonderful day here in Nuremberg. We will now head to the I/O forum.
Okay.
Because now our logic controller is probably the pinnacle of TwinCAT development, which we are doing for more than 30 years. So for more than 30 years we are doing software development at Beckhoff. But to be honest, even if you have a very, very fast brain, as we have just been shown on the wall, you need information and you need to interact with the field level. And for this, we are very, very proud that we have our I/O system. You can see a lot of people are already curious, are already looking at our more than 1,000 different I/O devices which we offer. But now we have added, you could say, a few more automation basics, new digital in and output terminals, a new family. Michael, what's about them? Why did we do them and how do they differ?
Yeah, we did it to bring the circuitry and the parts of the latest state of technology. Mm-hmm. So basically it's all modernized, optimized. From the functionality, there's no big difference from user's point of view. Mm-hmm. But it's state of the art now.
Okay, and that's really an absolute basic automation function. A digital input, asking a light switch, are you on and off? A digital output, making a light bulb on and off. Why did we develop these new terminals? So we have the same form factor. We have different components. What else can we achieve with this new design?
So we learned a lot in the component supply crisis.
Okay.
That older parts were not as well as available as the newer parts. Mm-hmm. So we increased our supply security. That was one important point. And we also did, for the high runners, 2 different designs. An A design with components from different vendors and in the B design. Mm-hmm. And with this, we have a higher supply security and we can also optimize the prices for our customers.
Okay.
And these were the 2 important points.
Availability up, price down, functionality constant or different?
Functionality, let's say 99.5% the same. Okay. So to give you an example, there is no big difference in a 24-volt 0.5 amp output.
Oh, it's standardized, yeah?
Standard. And the inputs is standardized also in the IEC 61131-2. But for example, there are slightly differences. For example, the switching time on the output. The existing product has a switching time turn off of 60 microseconds. The new product has a switch on time of 140 microseconds. So there's a difference. In reality, use it for solenoids and for contactors, and they need milliseconds. So in the practical application, you will not see the difference.
But what if I now have my special super fast 60 microsecond contactor?
Stay lazy, no need to change it. So the old product will be available for many, many years. We try to keep it available forever, as long as it makes sense from technical and economic point of view. But of course, for new products, the new product will have even a longer lifetime.
Okay, so we could optimize our I/O portfolio for our customers. We can bring down prices, increase availability with our experience from the market to supply a good feature set. And I think that's a wonderful basis for every machine because everybody can really need it. Michael, I would say thank you. Have a fun day here in Nuremberg, and I hope you will have a lot of interesting discussions about it and find many new customers with it.
You're welcome.
See you later. Not everything is gray in the automation world. There's also some color to it, and that's our safety portfolio. Martin, do we have any news here as well? I guess yes, because otherwise we wouldn't be standing here.
Yeah, but the main use is not a purely yellow component.
Okay.
You know from the past, I think that in the past with the AX5000 we already have a dedicated TwinSAFE controller for the AX5000.
Additional slide-in PCB.
Exactly. In the AX8000 it's already integrated completely.
Yeah.
And now we are also integrating the safety controller functionality to our IPCs. So we are basically taking the logic of our dedicated safety controller and inserting it into a standard IPC to do CL3 applications.
Okay. So the lines between gray and yellow world are becoming more blurry. What do I gain from it? What do I gain from it?
Well, on the one hand, all yellow components are of course based on microcontrollers. So they are very limited. With the IPC we are using, well, really current processor technology. So we have a Intel Core i whatever processor. So you gain a lot of performance from the processor point of view, and we can increase all the limits. So the project limits of the components are now, I think, 8 times larger than with the hardware solution.
Okay, so it's also about utilizing the possibilities of PCs and of IT technology. Okay, integration is the main topic. What else can be integrated?
Well, those are all examples where we do the integration. But if our customers want to do an integration, they can also use our safety components without housing.
Now we are really starting to sell PCBs on their own. Why would I do what I want to do that?
Well, for example, in the past, if you want to have a keyboard, for example, for your panel with an emergency button, you had to buy it from us with the wiring and so on. Now you can just take our PCB board with safety controller, or we also have it with inputs and outputs, and integrate it into your own device.
Okay. Are there also some devices where a Beckhoff housing is around it?
Yeah, we are also doing new components. By the end of this year, we are releasing our 1957. So 8 inputs and 4 outputs with 2 amps.
Okay.
So you can build a complete safety loop on one terminal.
Okay, that's also that's really a proper safety controller then with everything what you require, right?
You can do a complete safety loop. So inputs, logic, and output on one component.
On this size, or it's a double terminal?
No, it's this size. Yeah.
Okay. Wow. Okay.
Yeah.
That's very
and
small.
We are also doing a relay output component and the first safety analog signals in CL3. So we have 4 to 20 milliamps in one terminal for EL and also ELX for the X.
I'm happy to figure out what you can use these for in Hannover. Thank you, Martin. I hope you will have a great day. And we are now going back to Roland and Christian because we have heard gray and yellow IOs. There are blurry lines, but what you don't want to have is blurry lines when you make edge detection, and this is where you can use our vision components for.
And I thought this blurry lines is an actual pop song. We need to dance now. Now let's talk about optics and cameras, because you might know we have cameras and we have different optics, lenses for it. we have our illumination. So this is a portfolio existing. But now here comes the clue, because what we can also do is we can put these things together, 1, 2, 3, into one so-called unit. And Christian is one of our experts in the vision team. So Christian, is this really the best of 3 all in one box?
Yes, you can see we have integrated everything we are really good at. We have integrated illumination, and this illumination is quite similar to our large simulation you have recently seen over there.
Yeah.
We've integrated the same illumination technology, and when I say technology, I mean this is also a multicolor illumination, so you can do a flash in green, in blue, or infrared, or whatever. Furthermore, we've integrated a so-called liquid lens. This liquid lens can change its refractive power on demand. And additionally, you see here on the back side of this unit, this is the platform of our VCS 2000 camera, of our standard camera. Okay. So when you attach this camera to TwinCAT, it really looks very similar to our standard cameras. There are just some additional controls for controlling the illumination and the liquid lens.
Okay, so at the end, it remains at the basics, an EtherCAT cable and the data cable for the pictures, and that's it.
Yeah, that's it. Yeah, you see, you have also, there's also a very robust setting here. So you achieve an IP65, IP67 rating here, along with very many mounting possibilities, industrial grade connectors. So we want to make this product ready to be directly put into a machine.
So I think it's simplification. It really makes it so easy for the customer. Now, what I learned is that usually also the product which has to be inspected has different heights. Yes. And that's normally the can adjust this. Now, how do we do this liquid lens now?
Yeah, this is why we integrated the liquid lens. So the customer has the possibility to actuate the liquid lens to adapt to products of different height using the control. And you can even set up some kind of autofocus, for example, for setup purposes or so. So this means you take the image is transferred using TwinCAT Vision. It's analyzed in terms of some sharpness matrix also on. Then you give the feedback to the liquid lens, and then you can analyze the image again. And so you have a control loop which establishes some kind of autofocus. Huh?
Oh, so the lens has the control loop, but I think you mentioned this already quickly. Everything is TwinCAT integrated because we started today this session with TwinCAT. So at the end, it's a ready-to-go solution in hardware and software.
Yes.
Now, ready to go means I need it. So, Christian, when can I get it?
Yeah, this will be ready at the end of this year.
Okay, this is soon because we have already November. Yeah. So thanks for the update. Perfect.
You're welcome.
And now you need to spend 3 more minutes with us because we have some questions in the chat, and I have heard that Felix has another expert with him for the questions.
And of course, the PLC community is taking the news and already has some questions. The first question is about the command line interface. Can you use the command line interface with PLC++ as you can do it with the automation interface?
So all in all, I think there are 2 parts in this question. We are introducing the interface for the compiler. So it can be automatic, or an automatic process can be called. But it's also about the system manager side, I guess. So we are adding, or have already added with 4026, a standalone system manager component, which can be used without using the Visual Studio, so no engineering necessary to configure I/O, for example. So everything else, let's say, what's nowadays possible with the automation interface is possible via the standalone component. And these 2 components together leads to a fully automated process for generating and also building the whole project.
Okay, I understand. Possible, but I will ask you later on why do you need it and what's the benefit of using it. Another one, a very popular question, we introduced it not so long ago, is that we also offer different operating systems such as Linux. And will this be also something which works together with PLC++?
I think it's around the same topic because it's it takes more time to set up a Windows system, to start it for automized tests. So I guess the idea here is that you do the compiling on a Linux system or virtual machine, which is then way faster. And this means that the compiler also has to support Linux. And this is in fact the case. So it also supports Linux besides of Windows. So you can also use Linux as an alternative system for those automated testing.
Okay.
This is like every Beckhoff PC in the future can have Windows as an operating system, can have TwinCAT BSD, can have Linux, because we know how we build IPCs and images.
Yeah.
Absolutely right.
But you know what? It's important to have a fast and good brain, but it's also very important to have big and strong muscles.
Yes.
And that's something which we will address tomorrow. Behind me, we have a news which we will introduce tomorrow in detail. You can come visit us, discuss with Bela command line interfaces, Linux deployment of PLC++, with Roland about IPCs. And we would like to welcome you here on our booth 406 in Hall 7. And we are looking forward to meet you here or tomorrow again at 10 a.m. for Beckhoff Live and Interactive. Goodbye.
Bye.